Hello programmers, if you always wanted to learn about database migrations, well, consider this your lucky day, because we're going to learn a lot of theory as we usually do. We're going to take a look at the code, and we're also going to use a real database to have some practice with it. All right, so we're going to start with the very basics. So what do we mean by a migration when we say the word migration within the scope of databases? Okay, we usually mean two things. We either mean a schema migration, aka an actual database migration, or we mean a data migration. So let's take a look. A schema migration is an incremental change within the database schema, such as adding, modifying tables, column indexes, or constraints. Okay, literally this is making changes to your schema or database schema, like literally adding a table or modifying the table. On the other hand, data migration is migrating from one database system. So literally here's 1DB, you literally take all the data that you have here, you move it to another one, and this is your second DB, okay? Or let's say this is an old database, this is a new database, you upgraded it, and you have to move data from one to another. This is data migration. So when we usually say migrations, we often refer to the first one because this is happening in our day-to-day life as software developers. Compared to data migration, this is like a much bigger process that doesn't happen that often. Okay, so what is a schema migration? Let's say we have a developer here. Let's say this is you. You have a MySQL database running on your laptop locally, and you have a table called products. Okay, you're literally developing an app, and then you decide to make a change to your database. You're trying to introduce a new table called manufacturers, which means you also want to add a new column on your products table, and you're also going to reference these manufacturers by their IDs, hopefully, from your products table. So you're literally making two changes. You're introducing a new column, and you are adding a new table called manufacturers. Now, let's say you have another colleague, and they also have the same setup. Now, you have to go to your colleague and modify their database manually to introduce these changes. Or let's say if you have a database running on a remote machine, like an EC2 instance, you have to log in, you have to do the same command, run the same commands in order to achieve the same state, or let's say synchronize your state with the states of other machines. Well, as you already can see, this is not the ideal scenario because this is too much work to do, and you're probably going to miss some settings, let's say some column settings such as non-nullable, and then you're going to end up with different states on your local machine and on the remote. So this is why we need migrations. Migrations are basically incremental changes, and actually it very much reminds me of a Git or the version control, okay? Because we're piling up changes on top of each other. Let's say we introduced a new table, we introduced a new column, we changed the column settings, and so on. So this is basically the history that you eventually need to take as one, and then go to your colleague or your remote machine and apply them there, okay? Literally like Git. Now, what do we talk about with it? So I want you to actually take a look at the code when we talk about migration. So what is a migration? And actually, before we do that, let's literally mention that you're not going to do this migrations alone. So you usually have tools that facilitate this. So let's say we have Liquibase. This is probably the most famous one, but it's paid. You have to pay for it. And it's very much powerful because it can work with pretty much all kinds of databases and all kinds of programming language. For Node.js specifically, we have Sequelize, which is an ORM, and basically it helps you to retrieve data, insert data into databases, and can also do some migrations. We're going to take a look. So going back to the code, we have a Node and Express API. So our API is going to use Sequelize here. So we're going to connect to the database like this. We are going to have a schema that Sequelize knows when trying to access the database. And we're going to define two endpoints, users, and well, this is a get endpoint, so it's going to retrieve all the users. And this is what Sequelize ORM does. So instead of doing a SQL command yourself, like select star from blah, 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 you literally can say user.findAll. This is basically doing select under the hood. And the same here. For the post, we're going to take the name and email from the body of the request, and then we're going instead of doing an insert, we're going to do user.create, and this is basically has an insert under the hood. So you get the idea, okay? So we also have a database or DB folder here. A DB folder is mostly generated by Sequelize. So let's take a look at Sequelize's documentation. So you can install it and you can bootstrap it, and it's going to configure these folders for you: config, models, migrations, and seeders. So let's try to understand. The first table, or the first folder, not a table, has a config.json file. This is basically different configurations for the databases that you're going to be using. So let's say you have one database locally, you have one database on your test environment, and in production. Obviously, these are empty, as you can see, they're null, but I have a database running locally, or will have soon, and this are my credentials in order to let Sequelize to connect to it. Okay, when I run a CLI command. We also have migration folder, and we have this file here, which is going to be created automatically. Okay, it's going to be created automatically because in order to, let me go back to the board. In order to create this manufacturer's table, Sequelize is going to give you an opportunity to create this table and define all the fields that you want. For example, name, email, as you can see, those are strings, created at, updated at, and so on. And how does this get created? I mean, this is you posting this code, but you always have these two methods called up and down. Up is for running the migration, and down is for reverting migration. You can also revert the migrations, okay? So you can go both ways. And usually the way you start your migration is by modifying your schema, okay? Or model rather. So we have one model called user. Model corresponds to a table in the database world, okay? So we can initialize the model again. I think you already saw a model here in our Express app. So we define it here, but in order to interact with the database, we also need to define it here. So let's say we define a name, an email, and timestamp. This is for created at and updated at. They also have to be present. And basically, this is it. Every time we run a migration, we're automatically going to create a new migration file here. We're going to take a look at this, obviously. And we have seeders. Seeders are basically scripts to create some dummy data. We don't have any dummy data or don't need any dummy data. That's why we're going to skip this. Also, we have Docker Compose in order to be able to start our services. As you can see, we have a DB, which is a MySQL 8 image, and we need to pass some environment variables so that it can start. It's going to serve on a port. And we also have our app, which is a Node.js app. It's going to take the context from a Docker file. And we also pass the same environment variables to the Sequelize ORM. And the Docker file looks like this. We're using Node 22 and literally starting the app. This is literally it. And let's take a look at our package.json. Express, straightforward, MySQL 2 in order for Sequelize to work, and Sequelize itself. Okay, as simple as that. Now, let me try to start our services. I'm gonna try to use Docker Compose. So I already built the image, so I don't need to do Docker Compose build anymore. I'm simply gonna say Docker Compose up, and it has to start my database first of all, and later start the Node.js app. Okay, did I say build? No, I said up. So it has to actually build or pull them in case if the image is not pulled, and then started. So the DB started and app is recreated, and the app is listening on port 3000. Amazing. So let's verify this. Let's go to our database and make sure that we're still connected to it. So I'm going to refresh. We have our local host, we have our test DB, and we have our tables. Okay, let's see. Yep, I already have my users table, so I'm going to open this. And I'm going to see that I have one entry, Jesse Pinkman, because, well, I inserted it previously. Okay, we have one entry. Now, let's say we want to make a change to our database in order for me to be able to show you how migrations work. We're going to create a new column called age. So let's do that. We're going to go to our model here. We're going to create a new entry or a new key. So I'm going to say age, and I'm going to say data types integer like this. And now I'm gonna go to my other console and try to run the migration. So I'm gonna say Sequelize CLI migration generate, and I'm gonna give it a name like this. Okay, so the new file is created. And if I open this new file, you're gonna see that it basically gave me some boilerplate code. Now you might ask me, why didn't it actually insert the change for adding this little change? This could have been an easy win. Well, I don't know why, but Sequelize is probably not smart enough to be able to do that. That's why you actually need to add use some additional data. For example, you can use Sequelize auto migrations. This is going to automatically add this new column. Or if you're using Liquibase, it's going to automatically do that too. So let's not waste time and actually try to add this. So the way I'm gonna do this is probably I'm gonna copy this from here, or I'm simply going to ask ChatGPT in order to give me some code. Okay. All right. So we do live in the AI era. So don't mind me literally copying and pasting the code here. As you can see, what it gave me is basically this. So we're going to add a new column to our users schema or our users table. All right. And we're going to say integer allow null true. So it can be null true because it's going to be null for our first user that actually didn't have an age by the time I inserted it. And to revert it, we can always say just remove the column. Okay. Now, how do we make sure that this change is reflected in our database? Well, I'm going to go to my terminal again, and I'm going to say Sequelize migrate model db migrate like this. And now it has to run the migration. It says using environment development and migrated. So first of all, let's take a look at our users table and let's see if it has any changes. And it does have a change. We have a new column called age, and this is null for Jesse Pinkman. Okay, so this was successful. And you're probably wondering, what is this second table called Sequelize meta? Let's take a look at this. Sequelize meta is basically our version control for our migrations. So every time I run this command, db migrate like this, Sequelize is going to take a look at the Sequelize meta table and compare these two migrations with my two migrations that I have locally. And if there is change, it knows that it has to run a migration, because if I try to run this again here, it's going to say that there are no migrations were executed because database schema was already up to date. So it doesn't have to do anything. Okay, so it's kind of being smart. All right, now let's go to our API again and try to insert this new user. So I'm going to close this. We don't need to run any migrations anymore. Our app is running here, and I'm going to go to the client and I'm going to say Walter White. And I don't only want to retrieve the users. I mean, don't only want to create a new user, but I also want to give it an age now. Okay. So Walter White is going to be 50, but to do that, we probably need to adjust our code as well, or application code. So what are we going to do? We need to tell Sequelize ORM that now we are also expecting an age. So data types dot integer like this. And every time we post or make a create entry, we need to also consider the age here. So we're going to take age from the body, and we're also going to use age in our create method, or like an insert under the. Now that I saved it, I will have to rebuild my image because currently I don't have this set up automatically. So I'm going to stop this. I'm going to make sure that my image is rebuilt, and I'm going to start it again. All right. So now my database and the app are running. I'm going to go to the client and I'm going to make a post request, send a request, and I get 2001 created Walter White with age 550. I mean, let's take a look at our database, and we have Walter White and it has an age. Okay. Now let's try to retrieve the users with a get request, and we see Jesse Pinkman, age null, and Walter White 50. So we successfully ran a very simple migration. Okay, so now let's go back to the board and learn some details about it, because migrations are not as simple as this. So first of all, let's talk about data management. What this means is basically that we have to be very careful with our data. So our APIs can be torn down and recreated anytime. They're stateless, okay, stateless, but our databases are stateful. So in a usual scenario, what we're going to have is an API that's, for example, containerized, but your databases are rarely going to be containerized. They're going to be an entity that always lives there. And if your API is torn down, like literally it's gone and it recreated, it still connects to the same database that was already there. So what I'm trying to say that usually in teams, databases are a separate entity that doesn't get deleted and restarted, that like our, for example, front-end apps, Nginx servers, or application backends do. All right, so this is very useful to keep in mind. You're rarely gonna see containerized databases. All right, so let's talk about a code versus data separation now. So there are two scenarios that you're going to have when you're dealing with migrations within your application. So let's say you have an API, like a backend application or an app, as we call it in the code. You can have your migration living within it. What does it mean? So if we look at our app.js, let me actually close these. We can make sure that we have a command called Sequelize sync. You don't have it here, but Sequelize has a sync method that is going to make sure that every time this Node.js app runs, it's going to actually run the Sequelize db migrate command that we used before in order to make sure if there are any migrations that it has to run or not. What it means is that in case if something goes wrong, we're going to have manual intervention, because if the migration doesn't finish or it errors out, our application is never going to start, okay? Because the migration, it literally is living within our app. Also, if there's migration that's taking too much time, our app is not going to start. Also, we need an extra locking mechanism, which we're going to talk about here, right here, in parallel migrations, because you need to make sure that if you have two instances of an app, they don't conflict, okay, with each other. Also, this is probably good for small self-contained apps and teams without dedicated database engineers. Okay, so really small applications where you can safely have migrations run every time your application starts or dies. But we also have a case where a migration is completely separate from our backend. So what it does, it isolates the procedures, because if a migration is failed, it can probably be solved earlier or later, okay, depending on your DevOps techniques. Also, the app doesn't have to wait for the migration to finish. At least it can start and serve the users. So this is for like very big applications, because the code always needs to be in sync with the schema. And if there are many cross-functional teams, if you have enough manpower to manage these migrations or a separate database, also a very good idea. But let me tell you what, there is already a hybrid idea for this, because the main problem here is, I would say, this one, a locking mechanism. Because if you have multiple instances, and this is what you're going to have if you have like auto-scaling, how are you going to make sure that one application doesn't run the migration, or two applications don't run the migration at the same time and actually hurt each other? Let's take a look at this image. We have two instances, and both of them are capable of running migration on start. So let's say both of them start at the same time and they try to modify the database on start. What do you have to do in this case? So you have three options, which are basically hybrid options to two options that we discussed before. You can make sure that the migrations are run outside of the app container. You can use a separate container or a job in your CI/CD pipeline. For example, before running, just making sure that in your DevOps pipeline, you run this script for run migrations, and only then you can start the app containers. How do we do that? For example, if we look at our Docker Compose file, we have this thing called depends on. So we can literally define a new service that is responsible for only running the migrations. For example, the DB started, we run the migrations, and only then our Node.js app starts because it depends on it, okay? Something like this, migrations, and DB is also here, all right? You get the idea. Or if we want to be more advanced and sophisticated, we can also use Kubernetes jobs or init containers. Let's talk about this. Okay, so Kubernetes jobs is something that lets you create one or more pods and will continue to retry execution until one of the pods successfully terminates. Okay, basically, it's going to create a new job before all the other containers start in order to make sure that the migration has finished, or you can also go for init containers. Now, we're not going to dive deep into these two concepts, but these are viable options. If you want me to cover these two, let me know down in the comments as always. But basically, these are the differences. So for single instance apps, which is probably not viable, you would go with init containers. But I would say in most of the cases, we have multiple replicas of the app, and jobs are a more viable option in this case. Okay, something, we'll link it in the description so that you can read it in your own time. And you can also do some database locking mechanism. So, which means if the database notices that there's already one app modifying it, it's not going to allow another backend to start doing the migrations at the same time. Okay, now let's talk about do's and don'ts, shall we? Do's and don'ts are always the fun part. So don't batch unrelated changes within a single migration. In this migration example, we see that we're creating a table and then we're employees. The table is called employees. And then in the same migration, we're also inserting some values inside the employees table here. So these are two different operations that have to live in two different migrations. Don't do it, because if you pile up a lot of code within a single migration, it's going to be really difficult to revert them. All right. Also, don't change models without creating a migration afterwards. So there can be cases where you change the models here. Let's say we make some change to the user model, let's say as we did with the age, and then we literally don't run the migration and push the code and start the app. Well, this is a really bad practice because we literally introduced something new. We thought that we ran the migration, but the database is still looking the old way. We didn't do any change. So always make sure that you do the full thing. Also, do group migrations in separate folder by versions or features. Okay, because let's be honest, migrations can get very cluttered. So it's very good to maybe group them like this. So users, you can also, or catalogs, orders, but you can also still group them by versions like this. So V2, V1, and so on. You get the idea. Also, do use a dedicated DB user for running migrations. Don't use the default user. Use the dedicated one. Also, do ensure support for transactional DDL statements. So what are the DDL statements? Basically, transactions that can be revertible. Okay, transactions are revertible, and some databases like Postgres work very well, while some of them don't. So every time you choose a database or you have a database already, make sure that it has support for such DDLs, because reverting the whole transaction is much easier than not being able to revert the same transaction. Because if you already made the change if you're running a migration and let's say halfway it stops because there's some kind of error, then the first half of the migration, like in this case, it's already going to be reflected in the database, and then you have a mess because the whole migration didn't run. But if you have a transaction, if it fails, it's going to automatically revert this transaction. I think I already covered it in one of my videos on databases, so go check it out. Also, do make sure that you have proper testing of these migrations. For example, with the help of test containers. Also have a video, I'm going to link it. So what are we expected to do? We're expected to test this with the following steps. So we can drop the database if it exists. We can recreate this from scratch with the help of test containers, run all the migrations, seed it with some data, and verify that the table has the needed columns that we're expecting. Of course, this is some overhead because it's going to add some time to your CI/CD pipeline, but still very good practice. And finally, let's talk about backward compatibility. Let's say we added a new column to our database or renamed our database, but we have so many applications or so many other backends that are using this database that still haven't adjusted their application code. Okay, let's say we renamed our users model, right, to user data. And then if the application also doesn't change here, because let's say it's a different team and for some reason we forgot to inform them, then their application is going to start failing. So you always have to make sure that you are backward compatible. How do we do this? Also, obviously, make sure that you inform everyone. But apart from that, make sure that you add non-breaking changes first. For example, if you want to create a new column, make sure that the new column is nullable. For example, if nobody knew that it has to have a value, at least make sure that it doesn't break or make it have a default value. Also, always make sure you have deprecation messages in your APIs instead of just dropping tables right away. At least make the API return a warning saying, hey, this feature is gonna, or this key or this column is going to be dropped in the future if you don't. So make sure you use the new way, or check the documentation. For example, when renaming a column or creating a new one, and temporarily make sure that the users are still able to run their script, and then you update both old ones and the new column, the renamed one, okay? Or you can make your life and their life easier and just create a view whenever possible. What are views? Views are basically an alias, let's say, a bigger alias. So you can create a new view like this, S, and then underlying code is gonna be this. And then basically, oh, here it is. Create view Brazil customers. And then you can simply say select from Brazil customers. And when you do say this, it's going to run this underlying code. So as simple as that. So this is pretty much it, guys. If you learned anything useful today, and I'm pretty sure you did, make sure to like this video, subscribe not to miss any future videos like this, and leave a comment if you enjoyed it. I'm always happy to see those. All right, have a great rest of the day, and I'm going to see you in the next one. Goodbye.